Hi students, we have learned about the structure, name, etc. of Oxo Acids of Phosphorus, Oxo or Oxo Acids of Phosphorus. Here we have a list of Oxo Acids of Sulphur. There are a large number. Only few, we need not have to go to the names of all. Important ones we have selected here. Okay, we will see them. The question is the oxo acids of sulfur which do not have SS or OO linkage among the following. Okay, to answer that we must know the structures of these acids. First, see these three. Remember these three together: H2SO3, H2SO4, H2SO5. H2SO3 is called sulfurous acid. It is see all these compounds of sulfur in sp3 hybrid tetrahedral geometry. Please remember that. Here sulfur atom is having one double bond O and two OH. It is a dibasic acid. It is a very weak acid. Then we have H2SO4 which is orthosulfuric acid or sulfuric acid. It is having two double bond S double bond O and two OH group. And third is H2SO5. It is having a deviation from the regularity of the structures. See, this is a problem. If everything is systematic, regular, then it will have been easy for us to remember, reproduce, name, etc. If things are systematic, things will be easier for us to reproduce. But when things change at random, it will be difficult for us to remember and reproduce because we have to remember each and every case separately. That's a problem. Such a problem is there. Here H2SO5, it is not having another double bond O. Instead, the new O goes as a peroxide linkage. So it is having two double bond O, one OH and another OOH. It is H2SO5, peroxo monosulfuric acid, Caro's acid. It's a common oxidizing agent due to this peroxide linkage in the molecule. These three you please try to remember together. Now we have another set: H2S2O2, H2S2O3, H2S2O4, H2S2O5, H2S2O6. Only in the formula there is a rhythm system. But coming to structure etc. it is not that apparent. Let's see. H2S2O2. The structure is S double bond O, one OH and one SH. One may imagine that it is formed from here, sulfurous acid, by replacing one O by S. So this becomes this. H2S2O3 become H2S2O2. Sulfur increased by 1, oxygen decreased by 1. Okay, that is called thiosulfurous acid. Here, this SH is ionized, will be very less ionizable because mercaptans are not much acidic. This will be acidic. It will be definitely act as a monobasic acid. It's acting as a dibasic acid is doubtful or weak. Next, H2S2O3. It is called thiosulfuric acid. Try to remember the name somehow. It is. You can remember it in some other connection. We are familiar with the sodium thiosulfate, hypo, Na2S2O3, that react with iodine, etc. That's a salt of this. H2S2O3. From this we get Na2S2O3, sodium thiosulfate. Okay. So what's the difference? You can imagine it to be formed from here by replacing one double bond O with one double bond S. So formula S increases by 1, oxygen decreases by 1. Here also S increases by 1, oxygen decreases by 1. But there OH is replaced by SH. Here double bond O is replaced by double bond S. That's the difference. In both, one oxygen is replaced by S, but different type of oxygens are replaced in this pair and this pair. Third case, H2S2O4, Dithionous acid. It has a symmetry here. OHS double bond O, like this. Okay. It is called a dithionous acid. If you introduce one more double bond oxygen in one of the sulfur, we get this. If you introduce one more double bond O in the other sulfur, we get this. So there is a progress here. There is a progression here, which may help you to remember. So H2S2O4 become H2S2O5 and then H2S2O6 by progressively introducing one more double bond oxygen and two more double bond oxygen. Other thing by looking at, you can remember all these three are having SS bond. Remember, see Look here. This, and this all are having either as single bond S or as double bond S. That way you can remember. Okay. Now, remember names are given there. H2S2O4 is dithionous acid. H2S2O5 is disulfurous acid. H2S2O6 is dithionic acid. Dithionous, disulfurous, dithionic. Okay. Now, the other three more are there. Excuse me for the glare there. This is familiar acid, H2S2O7, pyrosulfuric acid or oleum. We are familiar with this acid in the manufacture of sulfuric acid. We first get this acid, and by diluting this, we get a concentrated H2SO4, H2S2O7. Look here, it is as if from two molecules of orthosulfuric acids, one water has been eliminated, whereby bringing in a SOS linkage. We have studied it in the case of acids of phosphorus. So, it is a pyro. Pyro means a product formed through dehydration by heating. So, that name is meaningful here. SOS. Okay. So, that is H2S2O7 or oleum. Now, suppose instead of one oxygen, if there are two oxygen in between, it is called peroxide disulfuric acid or Marshall's acid H2S2O8. H2S2O8. Okay. Now, if you replace this peroxide linkage by persulfide linkage, 2O replaced by 2S persulfide linkage, then you have tetrathionic acid. We are familiar with the sodium tetrathionate, where again in the chapter first year redox reaction, where estimation of copper by titrating with the sodium, by first mixing with the potassium iodide and titrating the liberated iodine with the sodium thiosulfate. If you remember, sodium thiosulfate is called hypo. During that reaction, iodine gets converted to sodium iodide by sodium thiosulfate. Iodine is converted by hypo to sodium iodide, and at the same time sodium thiosulfate get converted to sodium tetrathionate. If you remember, the reaction is like this: 2Na2S2O3 plus I2 arrow Na2S4O6 plus 2NaI. That was the reaction we studied. Okay. There the product is Na2S4O6 and its name was given as sodium tetrathionate. That sodium tetrathionate is the salt of this acid, H2S2O6, sodium tetrathionate, tetrathionic acid, H2S4O6, tetrathionic acid. Okay, so we can remember this much oxy acids of sulfur. Even though there is some difficulty, you try to remember all these acids. Now we will try to answer the question asked here. Going back, the oxo acids of sulfur which do not have SS or OO linkage. See H2SO5, it is having OO linkage. So it is having, so this is not our answer, do not have. So this is not our answer because it is having OO linkage. It is having OO linkage. H2S2O3, it is having S double bond S linkage. You can connect it as single bond or double bond, doesn't matter here, S linkage. H2S2O7, that is the other third thing here. It is neither having OO linkage nor having SS linkage. So this is So this is going to be one of our answer. H2S2O7. H2S2O8. We know Marshall's acid. It is having OO linkage. So OO linkage. Okay. And H2S2O6. This thing. H2S2O6. It is having SS linkage. SS linkage. So, question is that which does not or do not have SS or OO linkage. This is not the answer. This does not contribute to the answer. The question is those compounds which are not having SS or OO linkage. This cannot contribute to the answer. This cannot contribute to the answer. This can contribute to the answer because it is having neither. This cannot contribute to the answer. This cannot contribute to the answer. So this alone, only 3 is our answer because that is having neither S nor O. You may wonder whether to include this as double bond S. Actually, it is a problematic thing. They have if they have specifically persulfide linkage, only name is given in the question. You may avoid that also. Hope such a confusing idea does not ask in exam. Let them be specific about either it is S single bond S or S double bond S. So its case is doubtful actually whether that has to be included or not. If they are very much particularly mentioned as single bond S, you can avoid that. Or if they have mentioned in sentence SS linkage, you can include that. If they particularly mention persulfide linkage, you can avoid that. If they have simply mentioned SS linkage, you can include that. Hope you understood that. Take care.